This lesson will be on graphing transformations. So here we have the function that we want. So this is our transformed function. And we can see because it is a squared function, so we are transforming y equals x squared. So that's our parent graph. So let's draw the parent function first. You can see I've got my system of axes. When you draw your axes, please make sure that you have arrowheads on either side because our axes continue left and right, up and down to infinity. And make sure you label them. So I have my x-axis, which is the horizontal, my y-axis, which is my vertical. And then, of course, you have to put in your scale. It can't be something that whoever is reading your graph is supposed to assume or work out. So here, because I'm having 1 square is 1 unit, you can see every 2 squares I have labeled 2, 4, 6, or -2, -4, -6. Okay, so we're going to graph y equals x squared. So when x is 0, so we have 0, 0, we have 1, 1, we also have -1, 1. So you can see I'm just going to put in those points. Then we have 2, 4, and we have -2 and 4. And so that is our x squared graph. Now, instead of labeling on the actual graph itself, I'm just going to have just a key on the side, and I'm going to go by color. Okay, so now it's important to effect or implement your transformations in order. So the first one we are going to look at is looking at our a value. So this is representing a vertical stretch and a reflection on the x-axis. So what we're going to do is we multiply the y values of my points by the value of a. So in this case, it's by -2. So if my a value was just 2, I'd be multiplying it by 2. If it was a half, I'd multiply by a half. If it was -3, I'd multiply by -3. Okay, so that's how we're going to graph it. So now we're going to take each of my y values. So the x values are going to stay the same. So here, the y value is 0. So it stays as 0 because 0 times anything is just 0. I have 1, 1. So that's going to become 1 and -2. I have -1, 1. It becomes -1 and -2. And then I'm just going to do the next one. And next transformation we're going to look at is what happens because of that a half. So this is a horizontal stretch. And it's by a factor of 2. So what we do here is we multiply the x values by 2. So now we take everything from our pink graph and we're going to take all of our points and the x values are going to be multiplied by 2. So 0 times 2 is just 0, so that my turning point's not changing. However, where I have 1 and -2, I'm now going to have 2 and -2, and then, of course, it mirrors on the other side. And then I'm going to have 4 and -8. So we just connect our points. So notice we did I did my vertical stretch and reflection in one step. So you could do your vertical stretch or compression in one step. And then we did the horizontal stretch or compression. In this case, it was a stretch, but you can do that in one step. And if there was a reflection there, that would be part of that step. Then our translations can be done in one step. So you don't need to separate the vertical translation from the horizontal. So here we have a horizontal translation right by 2 units. So 2 units right. And we have a vertical translation that's 3 units up. With our vertical and horizontal, we are 2 units to the right and 3 units up. So every point, X value, we add 2, Y value, we add 3. So from my turning point, I'm going 1, 2, and then up 1, 2, 3. Then from 2 and negative 2, I'm going right 2, 1, 2, and then 1, 2, 3 up. And then I do the same thing on the other side. So my negative 2 and negative 2, I go to the right by 2 and 1, 2, 3 up. And then I have my last point, which is negative 4, negative 8. So I go 1, 2, and 1, 2, 3 up. And then on the other side, right 2, 1, 2, 1, 2, 3 up. And those are the points in purple that I need to connect. And so that's how we graph transformations. We start with our parent function and then we implement each transformation in steps.